Hello, my name is Beksot Hakimov, and in this video I would like to show you how the gas chromatography mass spectrometer looks like and how it functions. So this is a typical example of the GC-MS instrument. Well, we can divide it in different parts. Let me just show you. So the upper part, we call it a sample preparation unit. So here we can prepare a sample. The autosampler can take a sample from here, from the tubes, and it can place all the way to the agitators, which can heat and shake at the speed you set the instrument. The autosampler also cleans itself with a cleaning solvents, because after each new sample it's a good idea to clean the syringe, which is located here. And once the samples are ready, it will take an aliquot you set from the sample and injects into injection unit. So in this case it's a splitless injection unit. The second part of the GC-MS instrument is a gas chromatographer. In this case, I'm going to show you a GC which is from Agilent Technologies 7890B model. And you can see the electronics here. You can control the gas chromatographer from the panel here or by the computer. So this is how the GC itself looks like. Let me open the oven of the GC, and you can see inside here GC column. In this case it's a 30-meter semi-volatile column. In the GC oven you can see a column ending at two different places. So this is actually the place which is connected to the inlet. So when the sample is injected by the syringe, the compounds get evaporated and then they travel through the column here all the way. They make a circle inside the column and get separated from each other. 30 meters column. And once the compounds are eluted, they will enter to the MS inlet here. So once compounds are separated in GC column, they enter to the MS, and now I'm going to show you what will happen to them inside the MS. First of all, this is how the mass spectrometer looks like. So this case we have Agilent Technologies 5975C single quadruple MS, and you can see a small pump there. So that's the Edgeworth pump providing a vacuum inside the MS. And from this small window you can see an ionization chamber. There is a tube you can also see which is entering into the ionization chamber, and that's where the column ends and compounds elutes inside the ionization chamber. And now I'm going to show you how the inside looks like, because I have switched off the instrument beforehand. First, let me show you how this part looks like. So here we have a column ending. You can better maybe see from here. So this is where the column is ending. Okay, this is from where the vacuum is provided inside the MS. And this is how the single quadruple mass spectrometer looks like. And this part, we call it an ionization chamber. Here the fragmentation of the molecules are occurring. And how it's occurring: inside we have a filament which actually bombards molecules within 70 electron voltage electrons, and they break down the molecules, and the molecules will then travel through a quadruple mass analyzer which separates ions based on their mass to charge ratio and reach the detector, and we get a signal. So this is how the MS spectrometer works. Okay, in this video I just want to show you another model of the GC-MS instrument. It's exactly the same generation of the instrument, but you can see it's much more modern, and it's also big in size. So it has a, instead of quadruple, it has a time of flight mass analyzer. That's why it's quite big, and also big ionization chamber, larger and more high throughput sample preparation robot. It's called a multi-purpose sampler, and the rest of the things are the same. Using such kind of GC-MS, we can analyze volatiles and semi-volatile compounds. So by volatile, I mean the compounds looking like this, which are easily volatile, and when you hit them, they don't break down. They are thermally relatively stable, so they can travel through the column. And if the compounds having the functional groups like carboxylic acid or hydroxyl groups, what we can also do is we can exchange their labile proton by methyl or TMS derivatives, trimethylsilyl or just by methyl. We can do that by simple chemical reaction and inject instead the derivatized compounds and detecting GC. What we'll do is derivatized functional groups, they give them a more thermal stability, and they will lower their boiling point. So when you have a compounds like molecular weight of more than 1000 Dalton or the boiling point of more than 300, then unfortunately GC-MS is not a technique for analyzing those.